Okay, we're going to integrate the natural log of x squared plus 9. For this one, we're going to need to integrate by parts. And you wouldn't think to integrate by parts, really, because it doesn't seem like you have a product of functions in the integrand. But you do, because you're always multiplying by 1. And if you try u sub, it's not going to work. So what do we let u be? We're going to let u be this entire thing. So u equals the natural log of x squared plus 9. And then we let dv be 1. dv equals dx, because you've got a 1 in there. So then the derivative of u is 1 over x squared plus 9 times 2x by the chain rule. Don't forget that. dx. Over here we integrate 1. So v equals x. And you could go ahead and write the 1 if that helps you. So now we do integration by parts, which is u times v minus the integral of v du. So u times v gives us x natural log of x squared plus 9 minus the integral of v du. That gives us 2x squared over x squared plus 9 dx. So now let's look at what we have in here, because this is what we're integrating. So we could bring out the 2. We could do this. Bring out the 2. We're left with x squared over x squared plus 9 dx. What do we do now? Well, since we just have a single 9 that we're adding in the bottom, we could also add it in the top. But then we would have to subtract, because we can't just add 9 and then not subtract it. We could add 0, though. So let's do that. X squared plus 9 minus 9, so we've done nothing. We've just added 0. X squared plus 9 dx. Now, the reason we did this is so we could split the fraction. Since the operands we're using are just addition and subtraction, we could certainly split the fraction. And that makes everything much simpler. So we have negative 2 x squared plus 9 over x squared plus 9 negative 2, because remember this is being distributed to the entire integral. And we have negative 9 over x squared plus 9. And the dx is. Okay, so this just becomes a 1. This becomes a 1 because you have the same thing in the numerator and the denominator. You've got 1. Over here, it's a little more tricky. You have to realize that you need to use arctangent. Whenever you integrate something that in the denominator has x squared plus something, and in the numerator just has 1, or just has some number, you use arctangent. So how does arctangent work? How does arctangent, whenever you have this pattern here in the integrand, how does arctangent work? So the way it works is you square root whatever you have here, and then you let that go in the denominator under x, like this. Arctangent of x over the square root of whatever you have here. In this case, we have 9. So that's going to be 3. And you also have it under 1 here, like this. This is what we do in the case in which we had 1 here. If we just had 1, this is what it would look like. But since we have negative 9, we have to go ahead and multiply the negative 9 into this side. So that gives us negative 3. Now go ahead and multiply the negative 2 into this. We've already integrated. This is the integration of this. Multiply by negative 2, and we get positive 6. This becomes x. Multiply by negative 2, you get negative 2x. Negative 2x. And we have this, remember, because this entire thing came just from this. So we got that down. That became this. And so just add x natural log of x squared plus 9 plus c. And that's your answer.